So children, in my previous video, we started with the new chapter absorption by roots, and we discussed about that plants need water and how that water gets into the plant, what are the specific adaptations by the plant so that the entry of water is made easier, right? We talked about the root hair, its structure, and what is the particular characteristic feature of the root hair which allows that easy entry of water inside the plant. We discussed all that, but now what we are moving further with is movement of water. I hope you can see it written at the top of the screen, movement of water inside the plant, obviously, since we are talking about the movement in plants. What you need to understand here is that when water has to move into the plant, it follows a certain pathways or certain processes. The first way of getting water in or out of the plant is diffusion. You can see it written over here. Second way of getting the plant in or out is osmosis. And one more is there, it's not present on the screen as yet, that is imbibition. So three ways are there through which water can get in or out of the plant. Obviously across the root here only, but these are the three processes which will be helping for entry of water inside the plant through the root hairs, right? Let us discuss. I have made a comparative comparative form of this diffusion and osmosis. You can see I have drawn a vertical line and the points are written at the two sides. When you talk about diffusion, the first thing is you define it as the movement of molecules from the area of their higher concentration to the area of their lower concentration. This definition is written in your book, and this is a common definition used many a times. Again, I am repeating. Diffusion can be defined as the movement of molecules from the area of higher concentration to the area of lower concentration, right? Osmosis is also defined in the same manner. Movement of molecules from the area of higher concentration to the area of the lower concentration. So that means, moreover, the definition is coming out to be similar. What is the difference then? What is the difference? The first difference comes out in the form of that diffusion can occur in solid, liquid or gaseous states. All three states of matter can undergo diffusion. So solid, liquid or gaseous molecule can show diffusion. But when you talk about osmosis, you may say that it is a subcategory of diffusion only, because this is also movement of molecules from higher concentration to lower, but this occurs only in liquid. That means water or any solvent. Second difference is that diffusion is said to be done when there is a direct contact in the molecules. There is no closed chamber, there is no separations of the two systems. Here the molecules are coming in direct contact, and whereas when you talk about osmosis, here molecules of solvent or water are separated by a semi-permeable membrane. So what I am trying to say is, just for an example, when you talk about diffusion, we tend to use a deo spray, a deodorant, or sometimes we do use that mosquito repellent, that is HIT or something like that, or sometimes you might experience the fragrance of an incense stick. Whatever examples I have spoken just now, all these are gaseous forms. The smoke of incense stick or the deo spray or the say spray like mosquito repellent. These are spray, these are gaseous forms. Whenever you use such spray, you use them in the air, isn't it? There is no closed chamber, there is no confining limiting boundary. You just spray them openly. And we always come to know, though we are sitting in the next room, we always come to know that someone has used in some room or in some corner, someone has used the mosquito repellent or the deo or the perfume. How do we come to know? Because that fragrance reaches us, right? In an open system, the air molecules or whatever gaseous molecules are present in air, then you use the spray and this is an open area where both the molecules are coming in contact. So the point where you have used the DO spray is the origin point, so obviously the concentration of DO would be higher there, and the point which is slightly distant, it's not the origin, so it will be having a lower concentration of DO. So the DO spray molecules would be moving from higher concentration to lower. This is just an example, but what I am trying to say is that molecules come in direct contact, and after recognizing that which is the area of lower concentration, the molecules tend to move from one place to another. On the contrary, when you talk about osmosis, where the molecules are separated by a semi-permeable membrane, here semi-permeable membrane is also known as differentially permeable membrane or selectively permeable membrane, because it limits the movement of solute. It allows the entry and exit of solvent, but it limits the entry of solute. So whenever you have to express osmosis, you always show the two systems separated by a semi-permeable membrane, right? The common point in both the processes, diffusion and osmosis, that the molecules move from higher concentration to lower concentration. All right, just diffusion, slight elaboration of diffusion here. If you can see the factors affecting diffusion, so here the first factor is the size of the molecule. Let me give you some examples from your daily routine so that you understand this better. When you squeeze a lemon in a glass of water, so lemon is a liquid and water is also a liquid. Even if you don't stir the solution, in some time the lemon juice would evenly get distributed along the whole solution, across the whole solution. Similarly, when you make any kind of squash or any kind of like ruafza or something like that, when you use such things, you put the concentrate into water and you stir it. Even though you don't stir it, after some time it will be evenly distributed. That means from area of higher concentration, the solute molecules will go to area of lower concentration, right? These are the examples. One more example could be when you dissolve sugar in water. So sugar is a solid and water is liquid, and in some time the sugar automatically gets dissolved in water, because the place where when you pour one spoon of sugar in the water, it settles down, but where it settled down was the area of its higher concentration. So slowly and steadily the sugar molecules will dissociate into water and get evenly distributed. These are certain examples where you can express that diffusion is there. But if you just imagine that what if the sugar crystals are bigger in size, they will take more time to diffuse. But if it is a very small size crystal like salt, it diffuses very easily. So the size of the molecule is always it is a decisive factor for the speed or rate of diffusion. Smaller is the size, higher is the rate of diffusion. Then second thing is the area covered. Area covered is like if you are sitting in a big hall and you have sprayed a DO in the corner, it will take more time to reach everyone in the hall. But if it is a small room and then you use a DO, it will take very less time, because in very short time the DO molecules would be evenly distributed throughout the area. So smaller is the area, higher is the rate of diffusion. Third one is temperature. As simple as that. If you take cold water and try to dissolve sugar, it takes more time, but if you take hot water and try to dissolve sugar, it will take very less time. So temperature is something which increases the rate of diffusion. And fourth thing is concentration difference. Concentration difference, obviously that's the first requisition for diffusion, that there should be a difference between the concentration of two areas with respect to any diffusible particle. So if there is a difference in the concentration of two areas, the particles will move from higher concentration to lower concentration. After we have discussed so much about diffusion, I hope I have made myself very clear here. If you can see, I have drawn a small diagram on the screen. It's written here, diffusion and the movement of molecules from higher to lower concentration. It occurs in solid, liquid and gas, and it occurs when there is a direct contact between the two different types of molecules. This diagram just shows you that on one side, if you see the black dots, these black dots are normal air, normal gaseous molecules present in air, and the blue ones you just take it as any kind of perfume that you have used. So if this is the point, let me make this very clear. If this is the point where you have used the spray, right, so this area would be having a higher concentration of your perfume molecules which are in gaseous form as of now, and there is another area where these molecules were not present initially, or they are comparatively lesser in number. 1 2 3 4 5, you can see that they are lesser in number. So automatically the molecules will move from area of higher concentration to area of low concentration, and this is supported by the kinetic energy which is already present inside the molecules. I hope this much is clear to you. So just understand, there's a recap that water inside the plant moves by 3 different ways: diffusion, osmosis and imbibition. As of now we have discussed diffusion very clearly, right? I'm concluding this video clip as of now, and I'll be continuing in the next video. Thank you.